Good morning, everyone. This is Drew Allen. I'm the CEO of Grace Technologies. Thanks for joining our webinar today. I've got a pretty awesome guest who I've known for quite a while and who happens to work for us, Shelly DeGrate. Thank you for coming on and talking to us about 70B this morning.
I'm excited to be here. Thank you.
So, Shelly, you know a thing or two about 70B and a thing or two about switchgear. Can you give everyone a little bit of your background and why should they really trust you today?
Well, I have been in the industry for, we'll just say several decades. And I have gained a lot of knowledge, especially when it comes to products and OEM equipment, as well as now getting more and more into the standards work. So it kind of just parlays into what we're trying to do here at Grace and product development and making sure that we share our knowledge with our little Grace world to make sure our products stay in compliance with the standards and make sure that we're sharing that information with everybody.
So there was some big changes in the most recent revision of 70B. And also kind of the status of 70B really changed. Let's jump into that because I think that that's a huge kind of piece to start to discuss.
It really is, and it speaks to kind of the concern or the confusion that everybody has around 70B. It's now a standard as of last year, January 2023, and I have received a lot of emails about making sure that our continuous monitoring solutions actually align with what 70B is actually stating. And so, typically there is an evolution to these standards where they begin as maybe a guide, they move to recommended practice, and then they move to a standard, which is kind of the last step. And that's what 70B did last year on this 15th edition. So in this version, you'll see that prescriptive language where they move from the you should be doing this to you shall be doing this. So it's a completely rewritten standard. It really was designed to help facilities develop and implement a really robust and effective electrical maintenance program. So
as we're thinking about NFPA 70E or the National Electrical Code, that's really how the equipment should be installed. 70E is how should we behave around the equipment. But 70E is really predicated on the fact of the equipment should be properly installed and maintained. And so 70B is really that properly maintained component,
the equipment maintenance piece of it. It sure is. But one of the things that I really want to drive home is that OSHA has not adopted 70B into law, right? It is 70B as well as 70E is not a legally binding regulation. OSHA, however, can cite under its own regulations, but also other standards by which it has been, has an industry consensus of safety standards. So in other words, they can cite employers for non-compliance to standards that relate to safety, in and around this consensus standard. So, and how they do that is actually this bucket, this general bucket that it can fall in under called the general duty clause. And so this general duty clause is what really has led to many end user and companies to take a harder look at their electrical maintenance plan, as well as the products that they seek to integrate into their electrical apparatus as a risk reduction measure. So Section 5A1 says each employer shall furnish to each employee a place of employment free from recognized hazards that are causing or likely to cause death or serious physical harm to their employees. So you can see how that's kind of a catch-all clause, that if you're not complying, they can easily cite this particular clause as being one where they can point to cite you.
You know, before we get maybe further on into the standards, what are some of the big pitfalls of improperly maintained equipment? Let's talk switchgear specifically. What dangers does an improperly maintained piece of switchgear create for a site or an employer?
Yeah, well,
the employee.
We're definitely going to get into that here shortly, and I've got images and things that we can talk about. But around this theory of the industry consensus standards, I wanted to also share that IEEE, it too is creating a standard called the P2969. It's in the PCIC subcommittee, and it is entitled A Guide for Continuous Thermal Monitoring of Switchgear and Motor Control Centers up to 52 kV. So we started it in 2021. It's being written now, but I can completely see how as it evolves, like the other ones, where it could be one that could be referenced by OSHA as a standard to look to or to point to. So in this, just real quick, again, it's in development. We consider the topics of different applications, different sensors, installation, maintenance, and much more, like thermodynamics. Like thermodynamics is actually in the appendix of it. So really interesting standard that we're creating, not quite ready for prime time, but we have been working really hard on it for several years now.
When do you guys expect to kind of release a first draft, or what's the timeline on the standard development?
Well, we're trying to get it to ballot by our current PCIC in Orlando this next month.
So we just plugged PCIC in Orlando.
We did.
Shelly is on the planning committee, I believe, for that event. And so if you are going to be down in Orlando, we will be there.
Yes.
We're fun people. So
well, we want you to come into the standard subcommittees. We're doing a lot of great work.
We're fun people.
Oh, yeah. Well, standards is fun.
Okay, yes, correct.
Standards is very fun. So diving into 70B, we're going to be specifically speaking about Chapter 9. And Chapter 9 is around maintenance intervals. So this chapter really identifies the frequency by which maintenance of the electrical equipment should be done. So Table 9.2.2, maintenance intervals, really does a great job laying out the type of equipment, the scope of the work that should be done on the equipment, and the different levels of condition of the equipment, and how frequently you should do these maintenance intervals for it. So in this webinar, we're going to really focus on the thermography part of it, these annual inspections that they are asking the end users to do, these companies to do around all equipment. And depending on, which type of equipment and the condition your equipment is in, they give you basically the averages, the annual surveying. But specifically thermography, they talk about how these inspections need to be done on energized equipment annually. So in other words, prior to shutdown. And then more frequently, quarterly or semi-annually, if the equipment warrants it. So I like to see, for example, in this image, on the left is a piece of equipment. I call the thermography like a spot check informative view. But the problem is that on an annual inspection, that's less than 0.3% of its operating life is all the operating history is what you're going to see. So as the equipment begins to age, it becomes more important to obtain more and more equipment health. So as we move into the thermography, I want to just share how it really goes into how these two types of techniques, continuous thermal monitoring and thermography, can really complement one another to give customers the full health benefit of their asset. So in the chapter 7, for example, it really talks about the line of sight, and the normal circuit loading is when you have to do your thermography, and then, or at least at 40% of nominal circuit loading. So you can see how there is a level of risk associated with the thermographers that have to do this if they are having to open up equipment with being exposed to the energized components.
One of the comments I've heard way too many times is, we do our thermography every year during our shutdown, and we never see a problem.
Yeah.
And I asked them, well, is everything on during your shutdown? And oftentimes they're they start to realize that actually that equipment definitely is not under full load. And so you're not going to be able to see these hot spots potentially, as well as then obviously the safety hazard of equipment operating under full load is a massive concern. So there are some areas definitely where thermography is the right tool at the right time. But there's definitely limitations on both the safety as well as the ability to really predict failures and get a trendable data set.
Correct. In thermography, you can only see so much. So that's why I'm saying, they really complement each other in a lot of ways, in the sense that, for example, if you have an outdoor substation and you do your thermography in, the winter, say October, November, depending where you are in the world, this could lead to kind of a false sense of security, thinking that your full load isn't really as hot as it is. So there are definitely instances where they can complement each other well. And for example, in this image here, the image on the left, you can see that this would be a great place to do a thermal imaging. You've got your cable terminations right there in front of you, but this design really didn't allow for it because of how it was built, right? It wasn't planned for it.
You can only see two of the terminations.
You can only see A and C phase, so B phase is completely hidden. And the image on the right shows the deterioration of mechanical connections that also cannot be detected by your conventional metering of load measurements without de-energizing it. And, with today's aging infrastructure, I'm sure many facilities, have come into contact with situations like this.
Hey, just as a quick reminder, we will be taking questions throughout the webinar, so we don't need to just wait till the end. But I'll be breaking a couple of times to look through the chats and to introduce any questions over to Shelly. So feel free to start putting those questions into chats or comments that you guys may have, and we would love to address them in the webinar. All right, continue on, man.
Yeah. So we are starting to see this paradigm shift where the companies are realizing that, I love my thermography plan. I've got this annual thing going, but maybe, I can look to putting a condition-based or continuous monitoring solution of some sort in as well to complement it. That way I get the full picture health. And that's kind of where we're seeing, especially again, this aging infrastructure, where we're really seeing the shift in more people, including the standards, adopting and realizing that this is a risk reduction measure that they can deploy. So our solution is called, for continuous thermal monitoring, is called the Hot Spot Monitor product. And we're bringing this up specifically because NFPA 70B speaks to the fact that continuous monitoring or predictive techniques shall be permitted to be used now. So you don't have to be cautious about deploying a solution that will create a reduction in risk, but you just want to make sure that it aligns with this new standard. So for continuous thermal monitoring, it's called the Hot Spot Monitor product. And we're bringing this up specifically because NFPA 70B speaks to the fact that continuous monitoring or predictive techniques shall be permitted to be used now. So you don't have to be cautious about deploying a solution that will create a reduction in risk, but you just want to make sure that it aligns with this new standard. as we go through this prescriptive language in 70B, again, it speaks to the shalls and the shoulds of continuous monitoring. So it's really nice to be able to see how they have, how they've married the two together. So we're going to specifically talk about this table, which is in the appendix or the annex of 70B 8.9.1.1, which really segments each layer of equipment or sensor deployment that you can use to benefit yourself. And like we were talking earlier about an ROI kind of scenario where in this continuous monitoring solution, you not only can deploy it, but you can also take that and adjust your maintenance intervals accordingly. So if you've got a continuous, say in our case, a continuous thermal monitoring solution, you can deploy that, and as long as it is measuring actual values on a real-time basis and alarming, that's when you can actually expand your maintenance interval for thermography to something in excess of 1 year. So you can go 2-3 years if you feel that both in connection with one another are presenting the best health data that you can get on your equipment.
You know, this might be the first time I have ever seen predictive technologies listed in a standard. So I don't know if I'm wrong on that. You're the standards queen. But that's the first time I've actually really heard of predictive analytics being used to come to electrical kind of reliability.
It's certainly nice to see. And it shows you where the industry is shifting to. They recognize that the risk to electrical personnel is something that they want to try to reduce. So any kind of exposure, presents a risk. So anytime they can take that data and move it away from the equipment is a great thing.
Yeah, and I mean, in order to get to predictive, you do need loads of data and models, and so this is another area where a continuous thermal monitor that may also have additional inputs, for instance, coming from current or
Correct.
the humidity inputs or various other I/O coming into that sensor, now gives a much broader health perspective of the gear and can really predict and regress those trends into the future.
Exactly. And you can see in this table that the next level is the predictive techniques. And that is where you're bringing other sensors together to predict a health anomaly or a health situation that could be very damaging to the equipment or personnel or whatever. So we're gonna stay on continuous monitoring, but the next level is predictive techniques, that kind of AI analysis of what's going on in the equipment.
So one of the questions we have here, Shelly, from Kevin is, does CTM reduce the maintenance interval from 12 months?
It does. Well, it allows you to go longer than 12 months. It allows you to push that back to, like I said, 2-3 years, whatever you decide at your particular facility is the most appropriate. You might find over time that the data that you're collecting is actually giving you the best health scenario that you can get. Thereby, you can reduce your costs of production downtime and your personnel or your contractors that you have to hire to go out there. It kind of reduces that, expands that window of time that you have to do those thermography scans.
And we know what a rated temperature is on a piece of insulation that's going around a bus, right? So we're really trying to make sure that even with even in hot months, we're never going over that kind of insulation temperature rating and and various other things. And so expanding out our interval. I mean, the ROI on expanding out that interval must be substantial.
I'm sure it is in every industry across the board. Yeah, I'm sure it is.
Just going back to that 70B standard while we're on the interval is, so someone here said that their standard has been once a year, right? But duty cycles are also incredibly important, correct?
Correct.
And so if your standard has been a year, but the makeup of your facility has changed and how frequently things are duty cycling has changed, that would also alter potentially how frequently you have to do maintenance.
Yeah, your predictive techniques are now contributing to your electrical maintenance plan. All of it is a plan, and it's an evolving plan. But what the standard is saying is that they are now recognizing, and hopefully some of the insurance companies will too, will recognize the reduction in risk for incorporating these types of technologies that complement one another to give you that best health diagnosis.
Yeah, I've seen some videos of bus bar on motor inrush currents, and all this. I mean, it looks like it looks like you're in an ocean of copper moving through as that sine wave pulses through the copper bus bar, and so the stress on these joints on any sort of on or off motion is pretty substantial. It's a really fascinating thing to see those kind of physics.
Right.
And it's crazy.
Well, and that's kind of why we chose this particular technology that we offer here at Grace for continuous thermal monitoring, and that is that we utilize a non-conductive polymer fiber. So when you look to integrate it into your equipment, including all the way up and through your medium voltage equipment, we know that it has been tested for not only a repeatable performance, but also that because it's a non-conductive polymer fiber, we know that we're getting right on the hot spot. The potential hotspot, we're getting right at those mechanical connections that are the first to have issues. When they have degradation, breakdown, we have loose connections. All those are easily picked up and quickly picked up by a solution like this. And we like it because when you get down deep into the equipment, removing covers and barriers that you only want to do, once infrequently, you're able to get, really that information on a repeatable performance and you don't have to do any kind of calibration for it.
I really wonder what the statistics are that those barriers get put on properly after maintenance is performed.
Hey, human error is human error. We've seen it.
I'm sure no one's forgotten a bolt or a few.
It's just the nature. It's just the nature of humanity. You get in a rush. You're trying to get things back up. It happens. Right, it happens. But we really like the way our technology does it because we are not using a wire. We're using a phosphorescence technology whereby we are pulsing just an LED light down the polymer fiber. It's reflecting, off this compound in the probe tip, and it's reflecting back. So we watch that light wave attenuation over time to calculate the temperature. So, there's a lot of different technologies out there. We feel like this has kind of been a tried and true. It's been in the market since around 2010. We feel like it's a tried and true through all the different industries. Oil and gas is where it began, but it has evolved into industries across the board.
I thought it was fascinating that the original kind of patent on this technology, I believe, was Japanese based for MRI monitoring. Yeah, and so that was all the way back in the 80s, I believe. And so it's really come a long, long way, as well as orders of magnitudes of cost reduction.
Yeah, that phosphorescence part of it. Yeah, absolutely. They a lot of transformer manufacturing or transformer thermal monitoring was used with this technology. This isn't anything that's brand new to the market by any means. These are just the basic specifications of it, but I really want to highlight two things. One, that the standard really focuses on, and it's the ability for the continuous monitoring solution to have alarming capabilities. That's really important. Not only are you getting the real-time data in and being able to watch that over time, but also the alarming of them. And our solution has two two steps or two stages of alarmings that can be used as set points. And I think it's really important because you know where your high levels are, right?
Correct. The integration is incredibly important. We've had a couple of customers potentially forget to integrate, or maybe they didn't have budget to integrate. And the results have not been so good. There's a very large food and beverage manufacturer that went ahead and installed quite a few units in their facility. I was chatting with them kind of 6 or 9 months after the install, and it turns out that they ended up having a pretty catastrophic failure on one of their transformers. I followed up with them, oh my gosh, did the product miss it? Yada, yada, yada. He goes, no, Drew, your guys' product performed just as intended. And we were able to pull the data log from the charred remains of the switchgear. And sure enough, the data log showed increasing temperatures. And if only they would have had the budget to go ahead and integrate it into their alarming, their SCADA, their building management system. However you get those alarms today, it would have been really, really nice. So that they now make sure that if they're going to go ahead and budget for these units, they're always making sure that they include an integration plan. There's actually a question on that from Nelson. Can you be notified via your phone of any issues that occur? Yes, you can, not directly out of the unit. The unit talks Modbus RTU, Modbus TCP/IP, as well as Ethernet IP. You can go ahead and take those. You can take data from those protocols either into however alarming is done today in your facility, or we can also go ahead and integrate this into our GraceSense gateway and provide it via our cloud and give you a kind of a full data visualization view of that as well. Depending on how the architecture is really working in your facility, we have the ability to really flexibly access this data and provide it up kind of any way that you would want it to. We also have a question regarding the lifetime for the sensor. So I assume that they're asking for what do we anticipate from
yes.
kind of both
that's
base unit as well as...
That's a great question. Our team did an accelerated life test on this sensor, and it came to in excess of 75 years. So there is the way that it is formulated, there is the degradation doesn't even begin until likely the equipment is.
Did we put expiration dates on these units?
We missed that on the label. we missed that. We missed that on the label.
So a couple other questions. Talk to me about integration with some other kind of mechanisms of integration. So here we're talking about alarming, but really providing this data is the base level floor for continuous thermal monitoring before we get into predictive. But what are some other features and functionalities that having this kind of data set is able to enable on a piece of switchgear, for instance?
That's a great question. That's a great question. And as we look at the intent of all of the 70 70E and B standards, it's really about the health of the equipment. So one of the things, the features that we integrated into it is this feature of the discrete relay. And I felt that it was really important to highlight this one because this is a mobile substation. And what they did was take that internal discrete relay contact that when that temperature of that circuit, that you see it's a 6-bus circuit in each one of these compartments, as it reaches that high level, that discrete relay closes and they drive the fan. And so what's nice is that they don't have to have the cooling fan all the time, on all the time, but as it escalates, they can actually engage the fan and cool the circuit. So I thought that was a really unique application for it. And I've seen other people do other things with the discrete relay. For example, they put it into an annunciator or a data concentrator. To his point, some kind of a method by which to get an immediate alarm when it hits that high, which we'll talk about in a minute, but are settable based on your particular circumstance.
We also have folks who just go ahead and take the data and integrate it into their HMI installed, as well, or even little flashing lights on top of what are they called?
Beacons?
Yeah, some beacons.
Beacons,
well
horns,
to alert people.
not all the substations are manned. So these unmanned substations, they heavily rely on the communication to go, to their main.
We have a pharmaceutical install in outside of Dublin, and I believe they actually bring that into their security shack area, and they have an area that is kind of connected to their fire alarms, and so that's one of the ways that they monitor it using that relay.
Yeah, I've seen people do the comms through their protective relay and through their protective relay, through their data concentrators, through their PLCs, just however you can get that notification, as long as it's integrated and it doesn't happen to that, like what happened to that food and beverage company, that's clutch.
So there's a question here regarding being integrated with the customer's CMMS software. So if you do go ahead and bring it into our cloud offering, we have a native integration with Rockwell Automation's Fix. And you would be able to go ahead and tie that data set into Fix. If you do not kind of choose to utilize our cloud, which is fine, this device is fully cloud optional. You can go ahead and take this data into however you're providing information into your CMMS system today. So you can drop it into your PLC or some other mechanism, a concentrator, in order to provide it into your CMMS. We would love to find out probably more about what specific CMMS you're using, and then we can jump on a call with you and try to make sure we create the right data architecture.
Sure.
Mohammed's asking, is it logging the data to the cloud so I can monitor remotely or only local? The HSM itself is monitoring locally. In fact, I think that maybe the next screen.
It has embedded memory.
Right, but I think there's the architecture screen on the next slide potentially. This unit is data logging locally, but provides the connectivity out via Ethernet IP, Modbus RTU, or Modbus TCP IP by adding our gateway, either one of our cloud gates, either via LTE or Wi-Fi. We're able to go ahead and bring that data that's just local or even potentially inaccessible in remote locations up to the cloud. I think we've even had conversations recently with clients looking to put Starlink on their units, and as long as Starlink's talking Wi-Fi, we can go ahead and provide a Wi-Fi connection to the cloud via even a Starlink offering for really remote locations. Mm-hmm. Robert would love some more follow-up around the Fix integration. Robert, we do have, I believe, some webinars regarding our GraceSense offering and Fix, but we'll go ahead and get those follow-ups to you. Keep the questions coming in. We love to take them, and that helps us really make sure that we are targeting and answering what you guys really want to know. And also towards the end, we will be putting a survey. So if you want more information, feel free to go ahead. Oh, I'm being told it's actually now there's a survey. So if you're interested in getting more information on this, or you just want to chat with Shelly because she's awesome, feel free to go ahead and put some information in and fill out the survey, and we would love to contact and connect with you guys more.
Who doesn't need more friends? All right, bring it on. So these images, just little pictures here of installation of our particular product, medium voltage, cable terminations on the bus work, on switches, on fuses, low voltage, medium voltage. We've really got you covered with our solution. But speaking about connectivity, I created this little drawing because of a lot of midstream applications and customers that were coming saying that they had this outdoor equipment, and they wanted to make sure that they got this continuous thermal monitoring solution, but they didn't want to open the door. Not only opening the doors to their components are going to allow contaminants to get in and the heat and whatnot, but they went ahead and added the Grace port to allow them, if they did not have the ability to network it via the cloud or know that this unit is logging memory, it's got memory, it's logging the data in intervals, and then they're able to download it to their remote laptop. So as they get up to the outdoor substation, this unmanned substation, they're able to plug right in, download the data, and then say, come back in a month, I think is what they did, is on a monthly rotation. But in that, we have this embedded web page. So in this embedded web page, we have, all the things that you would do to make the setup unique to your application. Now we have some defaults that we put in it from the factory. The default alarming values are straight from the IEEE C37.20.2 standard. So it's at 90 and 105 is the high and the high alarms. Those can be modified. That's up to you. The internal relay, it can close or not, depending on your selection of the radio button. And then this is where you get your log information, and so put your logging set points where you download it, and it's all browser based. So there's no software associated with it at all.
Fantastic. We do have a question here. Are there any concerns about using these HSM or sensors in hazardous location? I assume they're talking class 1 div 1 or class 1 div 2 on low voltage 600 volt applications.
Obviously, this is not rated for a class, a class 1 div 2 or any hazardous situation. However, there are enclosures that it could go into that would satisfy that. So
just double clicking on that for a minute, you need to be able to put the base unit, the module, in a hazardous location rated enclosure. The fibers are non-conductive, and so there's no power running to those sensors. They are not really intended for outdoor use, though.
Well, they're not UV rated.
Yep.
However, most people just put them in a conduit of some kind, right, even if it's a flex conduit, just to give it a little bit of protection from the UV.
Yeah, Craig, we would like to get more understanding of your application, and so we can connect with you kind of offline to understand where you're looking to run these.
And then to further what Drew was talking about as far as integration, again, we do have, if you are a Rockwell-centric facility, we do have the EDS file that would be easily downloaded into the Rockwell platform, where you can, all the mapping exists, and it makes it super easy to do the integration of this particular product. But at the end of the day, like we were speaking about before, it's all about this analysis of health. So however you bring your sensors in, however you, whether you're looking at a relational relationship between different sensors, or just phases of temperatures in and of itself, to be able to trend them and map them is really of crucial importance. So, for example, on the left, you see the warning of the temperature increase with a constant current. That's something that would be an alarm for you. And then, but if you saw this linear relationship with temperature and current, expecting as current rises, temperature rises, then you would say, okay, that's not something we should be alarmed about. So just kind of putting a face and a picture to what your sensors are doing, how your equipment is behaving, is really the optimal goal for these types of technologies. And finally, 70B really, at the very first chapter, one of the first paragraphs, it speaks to that nothing in this standard is intended to prevent the use of systems, methods, or devices of equivalent or superior quality, effectiveness, and safety over those prescribed in this standard, which means they're very open to whatever your choice is to keep safety first, at the forefront of the electrical maintenance plan.
One thing we didn't quite hit on, for those of you who have not been involved in arc flash or have seen a piece of gear get blown up, when I've talked with folks who've experienced that, there's an immediate understanding of the dangers associated with being derelict in your duty to your switchgear. In the insurance realm, they call it a low frequency, high impact event. And let me tell you, every time I've talked with someone, it's been a very low frequency, but very high impact event.
High impact.
It's a really interesting thing. And I think that having this type of equipment installed and really bringing about these standard changes is really critical to keeping people safe, keeping your facilities up and running, and doing a much kind of better job of that. We do have another question. Any problem with using this on 600 volts and below? No, this is great on all voltage levels up to
52 kV.
52 kV. Are you able to set the sampling period of when you are collecting the data, or are these guidelines put out by the 70B spec for continuous monitoring data sampling?
There's nothing in the standard that speaks to that. These are our default values.
It is adjustable from once a minute to once a day, correct?
Yes, absolutely.
Yeah, so if you just start collecting a sample one time a day over the year, comparatively to a thermography inspection, that's a 365%
increase,
a 365x increase over the amount of data channels. And then I'm not going to do the math on air, but obviously doing it once an hour and once a minute, all of a sudden the resolution you're able to see your switchgear health with is exponentially larger. So there's not one set out, but it would be, this is a lot.
What we did is, if you were to log once every 30 minutes, you would get in excess of 15 years worth of data in the logger itself before it writes over itself. So I would hope that the download of the data would be considered long before 16 years comes.
Yeah, we're willing. We're gonna. What else do we have here, Shelly? Just the Q&A. Well, feel free to ask us more questions. We're gonna stick on here for another 10 or 15 minutes, and we are still excited to take any of your guys' questions. There will be a copy of the presentation getting sent out, correct, Nick? Yep, and so we'll be sending that out as a follow-up as well as the recording. So if you weren't able to screenshot all of our slides, we will.
Because you do it.
Yeah. Everyone screenshots the webinar slides, which is great. Just make sure you post this to your social media.
That's
to
right.
your LinkedIn. So Shelly, what are some other? So talk about what a typical project looks like. So, hey, I've got these 8 switchgear lineups. How do I decide where I'm putting these install locations? Walk me through what a typical project looks like. What does my interaction with Grace look like? What kind of help can we expect?
That's a great question. I typically get a 1-line diagram, and we go to kind of our default, which is maybe line load of a breaker, perhaps field terminations. It also is dependent upon, is it low voltage or is it medium voltage? All those factors work into it, but at the end of the day, users usually know where they typically either do thermography and they wish they didn't have to, or they would like to get some thermal readings and they can't get to it. So again, this is meant to complement what our thermographers are doing now and giving the customer just a broader spectrum of equipment health.
Yeah. One of the other important things too is just doing an overall criticality assessment.
Sure.
And I think if you haven't done a criticality assessment kind of in your facility, that's a really, really important, crucial step before we start determining which parts of the switchgear we need to be looking at.
Correct, right.
We should be doing a
Which
full
ones are
criticality
aging?
assessment.
What pieces of equipment are aging? Which pieces of equipment, are most critical, right? You've got to make sure the uptime is there. Those types of systems.
Yeah. Question: do the sensors come in different stud sizes? I maybe talk about how the
bolted connections. The sensor is just a probe, and the attachment, or what we call a fixture, is different.
Sorry, I screwed up. There's a photo later on the. On the
fixture. The fixture can come in different sizes. So the biggest, the biggest feature that you have to have on your fixture is that it's a 6-gauge. Of the ring lug, it's for a 6-gauge wire. That way, the probe fits in it. That's the only limitation.
Yeah. A question just kind of on costing. It comes in both a 9 and 18-point unit with the fibers. And I think we're currently at what, $350 a point, roughly?
Something like that. Yeah.
Will this be available via YouTube or some other? Yes, it will be available on YouTube shortly, probably within the next week or two. Couple days.
Close. Couple days.
What other kind of things do you think we might have gone either too fast through, or some other kind of important parts to hit that you've kind of seen come up, or?
Well, I think one of the things that I would really like to pub is the fact that there are so many standards out there, so many standards that are needing input from the electrical industry, and we would love to see your participation in the IEEE PCIC standards, and I'm sure watching the NFPA 70E and 70B standards, engaging these standards, because if you have a very, a big opinion, if you've got this experience and you've got this opinion, I really would encourage you to participate in the standards development, or at least the public input on these, so we can kind of see, where it is everybody's coming from. We have a larger swath of comments to look at and consider when writing these standards.
What's the maximum distance that you can run the sensor to the main unit? 15 meters.
15 meters right now, yes.
Correct. If there's anyone on the webinar who is going to PCIC, if you guys would go ahead and drop a comment, we would love to meet with you. We have a hospitality booth. Give the details for the PCIC.
PCIC will have a hospitality suite. PCIC is in Orlando. It's at the Hyatt. We will have a hospitality suite on Sunday and Monday night, and it's in the Celebration 8 conference room, and we'll have food and bev and a lot of demo equipment. We'd love to share with you.
Perfect. And please go ahead and take the survey before you leave. We want to know how we did, man. Make sure that we're delivering the right kind of content to you guys, and making sure that we're getting you the right resources to really be successful in your facility, keep people safe, and keep your plants productive.
Right.
Nick, anything further that we need to hit?
No, you guys got it all.
If not, we're going to go ahead and sign off. Please go ahead and connect with Shelly and I on LinkedIn, and we will talk soon. Thank you so much, Shelly.
Thank you so much. Thank you for being here today.